Troy Magennis is an experienced executive who has been involved in many leading software organizations over 20 years. Most recently, he founded Focused Objective to build tools and training for simulating and forecasting software development projects, including the Monte Carlo techniques, as described in his book, Forecasting and Simulating Software Development Projects, Effective Modeling of Kanban and Scrum Projects Using Monte Carlo Simulation, not a short title. And soon to be released, Lean Forecasting. So without any further ado, here's Troy.
Thank you. Thanks, everyone. No, I didn't get belted up on the plane. It gets worse. I found out last Friday that that Dennis said, can you fly to New York to do this? The same day I had eye surgery. So I was under anesthetic when he actually asked me, so I would have said yes to purchasing an alpaca at that point in time. But so anyway, if I look red in the eye, it's getting better. So this is a mixed deck. I took what Dennis was going to say, and Dennis and I agree on very little, including on how to manage risk. So what you're going to get here is a he said, she said sort of story about risk management, and I hope you enjoy it. There's me wearing sunglasses, which I should have been doing. I'm sort of a coach for leading Agile at times, and this is Dennis, far more attractive. I have more hair than him, but he's smarter than me in every other facet. He also dresses better than me, but I'm from Seattle, so I feel out of place if I haven't got my North Face on. My safety blanket's over there. So what we're going to talk about today is risk management. I apologize for the background of the slides. I know that the background's sort of washing out a bit there, so bear with me. We're talking about risk management in software, and it's sort of a subject which gets glossed over at times. No one wants to hear about risk management, but it's a very important part of software development, because until you can actually manage risks effectively, you can't go out and take risk in a calculated fashion. So I actually, last week from an executive, got told, he was a director level of Walmart, and he sort of said, I feel like I'm always giving bad news. I feel like I'm the only one that's ever introducing risk. I said, well, you're the only one that's ever pushing the boundaries about what can be done as well. You know, spin that around that, yes, by being good at managing risk, we know exactly what chances we can take. So risk isn't always a negative thing. That's our financial advisor friend would sort of say, right? I mean, you get the biggest returns when you take some risk, but you take risk. What would you say about risk?
I make return without taking risk.
That's right.
And if you get no return, you can't stay ahead of inflation. And inflation is a form of risk.
Very, very good point. Do you mind if I put you on the spot a little bit? You didn't forecast the Dow Jones Industrial Average. You left that as question marks for the future.
Yep.
Yeah, but you were willing to go on record of 2% inflation as an average, but you weren't willing to go on record for an average for the Dow Jones?
Well, the 2% inflation is actually a statistical number from the last 30 years. It's between 2 and 2.5%, so that's actually recorded.
Yeah.
So to make a projection, and a pro forma projection for the Dow will be by 2035 is dangerous. I mean, you could use historical averages to come back to 1802
Yeah.
and calculate it out that way. But then you would have to use Monte Carlo simulation to run 10,000 trials.
Come here, give me a hug. But
You'd have to use Monte Carlo simulation analysis legitimately in a financial plan to show 10,000 outcomes at a minimum to illustrate to somebody that every possible outcome from those numbers compounded and a series of numbers would give you that range. Because if you didn't do that, then you wouldn't be giving the full transparency and the full story to the people.
And that's the perfect answer, right? I mean, there are some things we can forecast easily by using a historical average. And with the Dow Jones, we do have a lot of historical data about the Dow Jones, but we're never certain exactly which angle it's going to fly off at a certain moment in time. And what does Nassim Taleb say? 80% of the Dow Jones change happened in 5 days over the entire century.
If you go back the last, Roger Ibbotson is a statistician who has been running analysis of the market since 1925 because he believes that's the year when he has full transparency on the numbers and statistics, so he could have factually correct data and stats on the charts and the actual market numbers. And he made the point that people talk about the market averaging 10% a year. I think maybe 12 or 13 times in the last 80 or 100 years has the market actually returned 10% in a given year. It's usually plus 5, plus 8, minus 10, minus 39 in 2008, plus 20, plus 19, plus 25, but very, very rarely is it actually plus 10 on the nose.
Listen, thank you. So even when we do have a lot of historical data, sometimes it is even hard to even project and make a calculation about what's going to happen in the future from that data. I think about in a software project, we don't even have that luxury. Every project's slightly different. We get very few samples of, we roughly know what's gone wrong in other projects using different technologies and different teams, but we don't really know what's going to happen next in ours. Sorry about that. I won't call you anymore.
I'm just going to make 2 phone calls.
No, you can make them now. No more picking on. So.
And that wasn't rehearsed.
It wasn't rehearsed. I actually did put him on the spot there, so thank you for playing. So what this talk is about, what Dennis does this as a one-day workshop. So I'm cutting it down to an hour, so I'm going to go fast through some of the material. But what he sort of says in this hard-to-read slide is that there's a lot of decisions that happen throughout a project. And every time a decision happens, you actually alter the outcome of the project. And what risks each one of these decision points get influenced by a different set of risks. So there's no way of actually knowing. Sorry?
Well, it's just the background is really
yeah.
read through all these slides. Just like
well, I don't have access to the. I mean.
It's should easy. I'm rusty with it though.
Well, no, there's no computer here.
That would be hard.
Yeah, I mean, I think it's underneath. But if we touch it, it's not going to work. I think the slides might get better. This is Dennis's material anyway, so I don't care if you can't read it. You do get the slides. I think they're already posted anyway. What happens is this is a slide I wanted, that there's risk applies to each of these decision points differently, and every time you make a decision, you alter the outcome. So the longer a project runs, the more decisions you make, hence more outcomes become apparent and apparent and apparent. And this is where yet we're expected up front to give a date and a deadline and an impact about what's going to happen. This is why forecasting software is hard, and this is why we get such a bad reputation about forecasting. You get caught between the lift well and the restroom and asked how long it's going to take to do a 12-month project, right? That's how forecasting is viewed at an executive level. Not defending them. One of my previous roles there, I was sort of a VP for Sabre Airline Solutions and Travelocity. So I was at the level where I used to hit people between the restroom and the kitchen and ask them how long would it take to do Project X. So I even knew it was unreasonable, but I didn't have any alternative to actually trying to get a ballpark figure about whether I should even go and fight for resources for a project. So there are reasons. Risks in general are classified as something that can go wrong that will cost you money. I don't overly like that definition. I think that risks in general, I prefer to spin it in a positive light, saying that by managing risk properly, we're able to take on projects which should be impossible to do. So risk is always talked about suffering a loss. What Dennis tries to do to counteract that is add on the suffix there, or loss or missing an opportunity, which is another way of saying that if we can't assess risk accurately, we don't know when we're missing out on something. So again, in my call last week, it was about telling that director, you're actually also surfacing opportunities that you can do, which they may not have realized because they thought the risk was too high. The risk has a lot of feedback. Now I am going through these slides fast because this isn't interesting stuff. And what Dennis says here is that Agile, through the Agile Manifesto, when it was kicked off, was about managing risk in a way. It was about almost like shielding the team in a room, giving them a finite period of time to work in isolation so that they weren't impacted by external risks for a period of a sprint and iteration. Risk management, I could boil it down to that. And it works pretty well for where we have a fair amount of certainty and even ambiguity because we pick things off in small chunks and we deliver them. But I'm going to skip through here. Traditional large-scale projects, which did risk management through the formal mechanisms that the PMI offer and so forth. Who's done risk matrices where you had to do a risk and a likelihood and multiply the two together? Everyone in the room has done that. Yeah, I'm going to try and tell you to stop doing that. By the end of the presentation, that is the key takeaway. Now, that type of risk management is down in this bottom corner, the waterfall approach to risk management. The only way we can avoid risks is by designing it all up front, understanding what all the risks are, designing our way through them and delivering in one big batch. But what that missed was when things were ambiguous or when they were dynamic, when they changed often, when you had to respond to your competitors in the marketplace quickly. Traditional risk management doesn't do that for you. And agile risk management doesn't do it for you because you actually incur risk through doing lightweight design up front and architecture up front. So I think most problems nowadays that we solve in software, especially websites or any .com or anything that's trying to move the needle in even an existing industry, are all in the top right-hand corner. It's a very dynamic market. The customer's changing, the customer needs change. You have many competitive pressures, and it's ambiguous. Well, we don't know what we're going to do. We just know that our competition is about to release a Kindle. How's that going to affect Barnes & Noble's bricks and mortar stores? Damn, we better build our own e-reader. Out comes the Nook, right? You see this responsive, this responsive nature. Now, what we need to do is we need to manage risk in that dynamic and ambiguous environment, and that's what Janice tries to teach, and that's what I'm going to show you tonight how to do. So, yep, apologize for these slides. I could read them for you if I could read them myself. But what we need to do is we need to take the best of the historical ways of risk management and move it into an agile light in a way that can actually manage this ambiguity, because they're sort of polar opposites at the moment. So, it hasn't gone unnoticed for the last 10 years. Of course, people have been working on ways around this. So who's heard of the Software Engineering Institute at Carnegie Mellon? Right. They brought out they brought out a paper which was intended for handling procurement, which set out a systematic way to do risk management for software projects. And I think they did the best job I've seen so far of articulating what risks you probably need to consider based on historical evidence. It's long and it's ambiguous because it's made for government procurement, so you can imagine the covering of the arse that happens in such a large document that's meant to go to a wide audience. But it is worth reading, and it's called Mosaic. I find the hardest thing about risk management in software companies with people is getting them to have an imagination for what can go wrong. And I think it's a good list of things that can go wrong. Read the Mosaic document and understand how they approached articulating things that can go wrong. Because as developers, we often try to ignore things that go wrong, and we just assume everything's going to go right because that's the way we want it to be. It doesn't really happen that way. Now, skip forward, I think, to 2006 or 7 when the Lean Startup, Eric Ries's book came out, and he sort of formalized the common sense approach of, well, let's do some experiments and see what happens. So he took the scientific method and applied it to business development and entrepreneurship, which is great. Good on him for actually getting it into print and making it viable, a few core principles to actually allow you to build a business in a risky environment. So what this presentation draws on is techniques from that as well about if we do smaller chunks in an agile way and we do more experiments to try and understand what risks we may be facing in the future, we do actually manage and control risks in a cohesive fashion. And what my expertise is in modeling a project's forecasting it, including the impact of risks, and watching and helping and tracking how those change over time to make sure that our model matches the way reality is likely to end up. So whereas we probably start out inaccurate, we know very quickly that we're inaccurate. We use historical data to normalize us, bring us back onto track, and from that point forward, we find out much earlier when we're departing from plan. So that's what I do. Yeah. Now, actually, every time I circled around on the plane, remember this is a one-day training course, so every time we did another loop because we were in a holding pattern, I deleted slides, but I wasn't able to get those slides on here. So what I'm doing now manually is skipping the slides.
You mentioned the modeling. For the modeling, do you have enough data to do the modeling?
That's a great question. Yeah. I will hold that over because I want to give you a bit of a background of the modeling first, and then I'll answer that question. But yes, the answer is you do have enough data, and I'll tell you why by the end of the talk. So one thing I've been looking at very clearly is historically, who did statistics at school? All right. I want you to forget most of that, but I want you to remember one very particular aspect of it, histograms. How often things occur is in a bar chart. Height is how often they occurred. Whatever there is along the x-axis is a measure of something you want to do. Now, this is something that I've seen through my consulting for probably 10 years, but not been able to clearly articulate why it happened. And in putting together this with Dennis, we now can say pretty well what histogram shape there is for risks and story cycle times in software projects. And this is important because that means we can use less data to infer. If we know the boundaries now, we can actually infer what the shape is going to be between those 2 points. So we need much less data to make a guess on. So here's the way it works. Normal distribution, the bell curve we're all graded on in school, happens if you sum together a measurement that has a tolerance. So if you measured 15 of the same chair back heights in this room, all manufactured by the same manufacturer, you would end up seeing a bell curve distribution in shape because there's tolerance in the way those chairs are assembled, and they're all meant to be the same height, but they come together. And it's called the law of large numbers. That any time you sum together a large number of samples from a population, chances are, well actually, categorically, it will end up being a normal distribution. Well, cycle time in stories and project risks don't follow that pattern because they're a set of work you know you have to do, plus any number of things that can go wrong to slow you down, but it is incredibly unlikely it is all of them, and it is incredibly unlikely that it's very few of them. So what we're doing is we're summing a base set of work plus n number of things which can take different times to do for every story we do or every project we do or every... It works at the macro level and the micro level. Let me show you. This is what I love, right? This is my life. I've written a custom language to simulate software projects, but I took it out of the other one. Monte Carlo simulation. I was told by the videographer not to move too much, so I need to stay still, which is killing me. But the way when someone says that, I might as well get it off my chest now. When someone says there's something that has a 25% chance of happening, like 25% chance of rain, if it does rain, you get wet. If it doesn't rain, you stay dry. But you'll see in risk likelihood versus impact tables, we multiply likelihood by the impact, and it gives us a number. Now that number is absolute rubbish because you can't multiply a distribution curve, a 25% chance of something happening by a number and end up with a measurement in the same unit that you started with. So when you join things which have a different likelihood of occurrence, you have to be a bit more sophisticated. And it's called convolution, which is a big word saying what we do is we have our histogram, our distribution of numbers, and we know that we want to work out what is the likelihood that 10 of those numbers summed together following that distribution curve, what will the result be? So if we had to do 10 stories in a software project, And we knew that each of those stories could be between 0 and 120 days based on historical data. But it's much more peaked to the left, around 20 to 30 days of cycle time. The way we would work out or project forward how long that project might take is by taking samples following this distribution curve, one at a time, it's called resampling, and summing them together. And then if we did that 10,000 times, what we end up with is, draw your attention to the bottom right-hand corner, is that as we do it more and more and more, it joins together into a distribution curve. Now, if you can take one message away from this meeting, I know I've used that line before, but take another message away from this meeting, is that when we give a forecast, a single date forecast is nonsense. Because there's so much uncertainty and variability in what we're joining together, that what the result is of a forecast is actually another distribution curve. There's a set of dates, a set of values that it can be, some more likely than others. And what we're trying to do in forecasting and risk is we're trying to set our level of tolerance across to encompass enough of those occurrences which did occur or could occur, but eliminating some of the outliers because the chances of that happening are beyond recognition. If we go too far to the left, we overpromise. There are so many more chances that the project will run long. If we go too far to the right, we never get funded in the first place. So it is important to not be at the extremes. So that's Monte Carlo forecasting and how it combines together. Questions? How's the pace? Too fast or too slow? This is the only math in the whole. So what I did was I simulated a base set of work and then up to 5 risks. And each one of those risks had a 25% chance of occurring. And if they did occur, they occurred at the same rate. Now, the base backlog was 50 stories that could take between 1 and 3 days. And what the risks are is 10 stories that could take between 1 and 3 days each. So there was 5 sets of those, up to a maximum of another 50 stories between 1 and 10 days, plus the original 50. Now when we, sorry, I don't know where to point it. So the baseline comes up to a normal distribution, or it would have if I did more than 5,000 samples, or 1,000 samples in this case. Law of large numbers, we had a value, 1.5 plus or minus 1.5 to get to, I said that wrong. I'm on camera, so I can't do the math in my head. I'm not going to do the math in my head anymore. Either way, there's a measure and a variance. We're running it through a system. It will turn out to be a normal distribution. Now, it gets interesting. If I bring into play the first risk, there's a chance, 25% chance of it occurring. And if it does occur, it adds to the backlog and we end up with a normal distribution being shifted over, but of lower magnitude, because there was only a 25% chance of that risk coming true. So there's still the majority of the cases are in just our 75% of the cases are still just in our backlog being groomed.
So what are you measuring?
I'm just measuring the number of days to complete a project, or the number of days based on 5 risks that could be in play, unlikely all of them, unlikely none of them. So now here's 2 risks. You see now it starts getting more peaky and we end up with these outliers out the bottom. They're the ones which happen a lot in software. If 2 risks come true in the software project, that's going to be the impact. 3 risks, 4 risks, and 5 risks. Now, it's getting hard to tell, and if I did many more thousands sort of simulations, but I just want you to draw your attention, just draw your eye to the peaks, and just draw a line down through those peaks. It ends up being something that is very well known in the statistical world called a Weibull distribution. And we're lucky, because this is the second most studied distribution curve on the planet. And it's studied because it's the basis for all reliability factors. Every time you fly on a plane, the reason they know when to change out the parts on the plane is based on the Weibull distribution telling them how long it takes parts to wear out. I know this is math heavy at the moment, but I'll bring it back to to how it manages risk in a second. And this cycle time chart is from a client here in Philadelphia, which has 10,000 developers. And this is real data. This is their actual cycle time data for their stories across about, I think, 2,000 or 3,000 developers. And it follows, when you use some clever software to do curve fitting, it follows the Webull distribution. And I bet yours does too. In fact, whenever I go to consult in an organization, if I plot I get them to give me the historical cycle time data for their projects, how long it took to do all their projects and how long it took to do their stories. And if it doesn't fit the Webull distribution, I don't take the contract because I know that someone's playing with the numbers or not giving me the right numbers, because I don't think it's actually possible for the numbers to be anything different without some external factors at play. Enough about that. I took that slide out. Okay, we're going to move on now. I'm going to bring this back in at the end about how we would use that to forecast risk, but I need you to have a good 5 minutes, 10 minutes for that to settle into your head. Mosaic, go and Google for it and download that document. What it is about is identifying risk factors in software projects. And that is your first step to sort of risk management. It breaks it down to 6 categories, but I think there's about 30 different sort of drivers which they have in play. And I know what Dennis does when he does consulting in this area is he goes and reduces down to 5 core drivers that you have to sort of think about. So that's why I used 5 in that previous example. What these drivers are is a success state and a failure state statement for each of the different types of drivers that you're looking at. I'll go into them in a second, but what the Mosaic approach tries to get you to do is express what success and failure is for different types of risks. And that'll come clear in a sample. So I'll just go to the actual driver itself. The success state, I'll read it because it's hard to read. The product is appealing to consumers and increases customers using automated systems for bank deposits. So what Dennis does, this example is a system which scans checks, does the checking of, digitizing, scanning of it, OCRing, working out what your check deposits are. You're all using it on your phones now for Chase and so forth. But what his workshop is a workshop around risk management of that project. So they're all written in this bank deposit sort of form. So one is that the customers actually adopt it, and the failure state is the customers see no need for it. They're happy with it just putting it in the deposit slot and having it be put into the account 3 days later. But there's people like me who just love getting the printout of the scanned check and just sort of saying, I wonder if it can read this. So we know it was success in hindsight, but up front, imagine you were the business person trying to get that project funded inside an organization. There's certain risks that you would need to overcome to make sure that was the case. And that's what this Mosaic process helps you do. Now, the business ones are a bit boring for us. We want the technical ones, right? So the technical drivers there is that we've got the tools and technologies that are sufficient to support the delivery of the platform. Have we made a choice? Is there a choice that's actually available to us? What about performance and so forth? There's a lot of questions around technical. But Mosaic walks you through building these success and failure statements and then drilling into what are the factors that would actually cause those failure states and success states. It is better than starting from scratch, inventing your own system. And it's a great source of good ideas. So go read the document. Feedback, organization, environment. This is a good one. Do we have the right staffing to actually build the project? What's the political situations? Are staff going to be pulled off our project to other projects? All things that happen to us on a daily basis, right? Organization, environment. Are our team staffed with testers? This is the stuff I deleted from all the deck while I was circling over JFK. Dependencies are the biggest one. In my career, I've worked for companies where the hosting and the networking equipment was outsourced. So we were really good at building software and getting it to staging. And then we would always fail on that last step where where our own internal staff weren't responsible for setting the configuration options and setting up the networking firewall rules that went to someone else. And that's where things fell apart. So even though we could deliver the software on time, we couldn't deliver it to the customer on time. So little details like that, right? But they're the things which burn you in sort of software, because you still get the blame for it. It sounds like you're just making excuses. I'm still going through counseling. But so, yeah, you can tell I'm more of the detail guy. I think identifying the risks is one facet that is so specific to your situation that I'm not going to cover much more than what I have. The Mosaic document is a great starting point. This is what Dennis coaches in. He coaches in how to get teams to identify these risks. And now we get on to the interesting part, the assessing of the risks. And to me, once they've been identified, that's fine. Now I need to know a likelihood and an impact if they come true. And that's risk assessment. Now, Mosaic actually helped here as well. If you go into a room and you ask someone, how likely is it that we're not going to get the right number of development staff and testers for our project, you get stared back at for quite a long period of time before someone breaks the silence. It's hard. How do I know? How do I know what the Dow Jones is going to do over the next 6 months? I know what it did over the average of the last 50 years, but you're asking me to go on record about what's the impact if these things come true. And what Mosaic did in this approach was they helped you set up the events that would need to come true for those success and failure criteria to be met. And then what you do is you assess those in a binary form rather than just an open-ended question about 0 to 100%, how likely is it going to occur? And this unblocks the thinking process for when you ask developers or any engineering sort of person, they're such detailed people. Their mind goes to the far corners of something that went wrong back in 1967 in their career. Okay, that's why it's so hard to get people to commit to, and why sometimes the story mapping and task breakdown exercises take so long with a large number of developers. It's hard for people to sort of move up above it. Now, what these techniques do, which we're going to show you, is get you to break it down to a set of events that would need to come true for a risk to be fulfilled, and then get you to just do a binary yes or no whether they are in place or not, rather than having to guess theory numbers. And this is how Dennis does it. He gets the team to rank them on a board and write for each risk across the top. He gets them to write down the drivers the events that would need to come true for things to happen or not happen. And then he does the classic mistake that I said earlier of actually taking the likelihood and the impact and multiplying them together. Now, he gets a small pass here for, it's like sort of ice skating where you get technical merit and then sort of artistic. It's better than nothing. I'll stop there. Because what it allows you to do is actually measure your progress to solving those risks. Because when you multiply the numbers together, the idea of multiplying the numbers together is to sort of say, if something is highly likely, we need to address it. And if something has a high impact, we need to address it. So by multiplying them together, you're able to get a weighted score that actually allows you to deal with those two combinations at one time. That's the idea. So what you do when you have these risks and you work out what their impact and their likelihood is, you multiply them together, and as well as any other burn down chart of progress that you're having for how you're completing or how a project status is going, you also burn down risk. And why do you do that? Because you want to reward people for anything they can do to actually reduce those risks or eliminate those risks. So by making it visible to people, you make them aware that there's something they can do about it and that you're actually proactive about managing it. So this is where it heads. We got two feature burn-up charts here. So let's just call them Project A at the top and Project B at the bottom. You got sprint 1, 2, 3, 4, 5, 6. The sprints across the x-axis. Some point value of scores or features that are being delivered. And then you've got just a linear regression about how long it would take you at your average velocity to deliver. Who hasn't seen a chart like this before? Good. Okay. Which project's in better shape, Project A or B? So the blue line is the features that are completed against what the linear regression is. So who thinks Project A is doing better? Who thinks Project B is doing better? So no one thinks, and then, okay, so everyone who voted thinks Project A is doing better because the blue line is lagging below the red line. Well, I'd say you have no idea because if this team just picked the easy stories to do, the ones which had no risk and didn't burn down the risks, then what this team has done is do all the risky stories up front, which meant they moved slower. But as we don't know the rest of the story is going to be here, as this team has to face and tackle those harder, risky problems, they may flatline and be late. So a burn-up chart of features and story points alone of velocity is not enough to get a picture of health for a project. That's the third takeaway for tonight. If you combine that with the risk burn downs, you can sort of see now that the team B on the bottom, in fact, did do the risky, they addressed risk up front in their project. So they burnt down a lot of risk very quickly, whereas the team A didn't. Which project's in better shape? Who thinks Project B? Yeah, so this is all Project B here, this is Project A. Yeah, that's right. So this is the key point. If you do get a set of risks that you think is happening on a project, and you do get a fair assessment of likelihood and impact, and you do multiply them together, it does allow you to approximate which teams are actually burning down risk in a more effective fashion than the others, which gives you more confidence that your velocity burn down or burn up chart is actually an accurate reflection of completion. Anyone not get that point? Everyone's too scared to say something. Am I going too fast? Too slow? Can I get a time check? Because I don't have a watch. Ah, good. So, I skipped over how people allocated the likelihood. Impact, it's up to, there's no fair way of doing that. You can do a 1 to 5 rating just to try and get them in order. You can use days, months, weeks, years. I've seen them all used. Whatever you use, you just got to be consistent across all your risks with the same unit for impact. Likelihood is far more subjective and hence interesting to me. The Mosaic framework said, well, let's give them a guideline to what 1, 2, 3, 4, and 5 means. Driver is almost certainly in its success state. Driver is almost certainly in its failure state, and a bit of ambiguous color in between. Now, there's a great book by Douglas Hubbard called The Failure of Risk Management. And he would be up here with his hands around my throat about now. The jury is out whether this is actually, even given these terms, whether the human nature in estimation will be able to differentiate between those. It's such a personal decision about whether something is in these areas that law of large numbers mean that this will be the average no matter what we do. And if it's the average of how people are assessing likelihood of risk, then we really aren't getting anything out of our risk management framework at all. I make it one step worse. what I did was I actually went and allocated percentages of likelihood to each of these, which suits my benefit. I'll show you why, because I showed you my custom language before where I had different models where I had the skip percentage. By using the Mosaic framework and getting people to be just qualitative in actually scoring whether a risk is likely to be in its driver failure state or success state, I can actually go and actually populate the risk drivers, the amount of times they're going to occur, and then I also can actually go and quantify the impact in days or weeks or months or a distribution of uncertainty around each of those individual risk drivers. And what that lets me do is build this multi-peaked curve. Now, this is actually a real one from about 5 years ago. And this is what I actually presented to my executives. I didn't hide the fact that we weren't certain of an exact date. I actually showed them that there were 3 main peaks, combinations for things that could go wrong in the project that caused delay. And then I made them a promise that that date that I said was the 95th confidence interval, which means out of my simulated runs, 95% of them occurred before this date, would always move left. It would never move to the right. So the date would always be getting closer. It would never get longer. And then what I set my team the challenge of doing is reducing the peaks. So after the first couple of weeks, I could see that the risk which was causing the outlier to occur was starting to be addressed. And the 95% confidence interval was actually moving to the left. So the date was okay. And then so on, another month later, until it ended up being, roughly the 95th percentile of one of the risks in the center here. Now, this was actually moving a large number of servers from London to the US. This wasn't even a software project. But those risks were very much that our vendor doing the firewall setup would be non-responsive, that we would get to the point where performance would be unacceptable from a user sitting in London. So there were very broad risks like that. But I'm just trying to tell you that executives tend to understand risk more than you would think. So don't hide it from them. Show them your uncertainty curves. Go ahead.
Could you please go back a couple of slides, the previous one? Why do you have the likelihood of 90% for the failure?
I wanted to, when people said something was in this state, I wanted them to be absolutely certain that there was only a 10% chance that they were 90% certain it was going to occur. In other words, that it failed. That risk was going to come true.
So this is like certainly they thought, okay, that's very,
Yeah.
the likelihood was 90% for that.
That's right.
But maybe there would be 90% to be the first one.
You would.
The driver is almost certain.
Yeah. You just got to keep the polarity. See, I keep moving around. I don't know. It doesn't matter as long as you work out. Do you want to say whether whether risks are going to happen, or do you want to say whether risks are going to be avoided?
These are just numbers. So this depends on
Yep.
how they talk about
Yep.
that state. Okay, thank you.
Yeah, and the idea was to give them textual descriptions to make them commit rather than having to work out whether, because someone's 10% sure is another person's 40% sure. That's the problem.
That makes sense.
I just tried to put numbers on them so that anyway, that's how I do it. I walk the executives back through this at my one-on-ones every week. They knew where they were. Yes, I had to take them to lunch and explain it to them the first time so they didn't look stupid in front of their peers. But it's the only way that you can really communicate the risks that and uncertainty you're dealing with in your software projects day to day without making it look like you're making excuses. There's some great slides when you get them. I go through some wording about how to do that. So, integrated risk management, which was where we were about on this topic. It's about There's no way around it. You have a project to do where we often set the developers the task of asking them how long it's going to take to do. We need to maybe do that, but do that very quickly, and then we need to ask them what can go wrong. That's the first step. Identify your risks. Start asking the question about what can go wrong rather than what can just go right. What you do then is you end up with a large number of risks. You will assess their impact and likelihood. We can differ on approach here. Dennis multiplies the two together and sorts highest to lowest and works on the risks in that order. I work on the risks just in impact order. I don't even worry about likelihood, because if it comes true, I want to know that I've actually addressed the largest risks. Your call. What you start doing then is you start putting, I think the next slide shows it, you end up with all your risks that you're going to work on. Start putting it on a task board just like you do your tasks, and put in mitigation stories into your project early. This is what we talk about when we talk about integrated risk management in your Agile projects. It is about making sure that risk mitigation stories get equal billing with business revenue and value stories, because if we do the risk mitigation stories correctly early, our project will be in a known state of health throughout the project. Oh, he's holding up a sign, 20. So, integrated risk management means next to your storyboards, next to your task boards, put up a risk mitigation board. And the beauty of this is that some of these mitigations go to your boss's boss, which is fantastic, because now you can actually ask them to attend the stand-up once a week to go through their stories and give you their status and us. And it makes them understand what you're dealing with. It's the dark matter in projects that you often don't get to talk about, because it sounds like you're making excuses and it sounds like you're being dire. But you're not. So, yeah. Now let me just, I had a question I had to get back to. Haha. Haha. The lady who asked it left. Oh, she'll be coming back. I'll hold this. First of all, any questions so far?
Your risk board, the mitigation, this one.
Yep.
They're tied to specific tasks, though, aren't they?
Sometimes. Some of them are like, I think they change throughout the life cycle of a project. Up front, you tend to do the staffing and organizational sort of issues. And later on, in the early part of the project, the risks are is that you don't have, that because you're doing architecture just in time, there's a risk that you want to set a spike for someone to go ahead and explore to make sure that you can actually achieve what your next set of tasks are going to be. So I find when I see spikes in a normal project story backlog, that's an indicator to me that there's a risk that someone's trying to mitigate. So I go and explore that with them. Why did you put this spike in there? Oh, because we're worried about performance. Ha! I found a risk. Let me analyze that some more. Because if one person has a feeling that they need a bit more information before they understand what they're going to do, chances are there's an underlying root cause you can actually follow on. So I find that by having a risk board, your spikes tend to move across into mitigations, which is a good thing, because once someone actually comes up with a risk in general, everyone starts feeling more comfortable about talking about things that can go wrong. Well, I was also worried about, this framework's written by 2 school kids in the back of Mountain View, and I don't know they're going to be around much longer. So there's a lot of risks that people know in their gut, but they're unwilling to say, because you know what developers are like. We don't date well. We're social or incompetent. We just generally don't like speaking. So by making them visual, you empower people to actually jump in there and actually volunteer things that can go wrong, their worst fears. Makes sense? And then, keep them around. This retired list, if there's one thing I steal when I leave a company, it's that retired risk list, because chances are they're the ones which are going to happen on my next project. So they're a great asset for the company to understand what risks did go wrong in our company, in our situation. So don't throw them away. And now we're up for overdue. So, sorry, go ahead.
That retires us, that's only ones that actually came to fruition?
No, it's the ones that have been mitigated. I tend to put a big red star on the ones which actually did come true, even though we tried to mitigate them early. Now, the question that came up earlier. Clicking wildly. Prediction intervals. This is my favorite. I travel with a set of die. Whenever I go through customs and they pull out this little bag and I open it up and there's all 20-sided die, they all get, you a gamer? Yeah. So, but prediction intervals is something that will serve you well just in life in general. If you understand likelihood, and this comes from the best way I heard this described was in a book called The Mathematics of Sex. And it had such a great title that I actually went to see the author speak at a university, and she used to do the entrance seminar for all students that were joining university because that title was going to get everybody going to this course. And it was trying to convince them to leave the soft sciences like medicine and psychology and move into mathematics and science, the good real sort of fields, and economics as well, I'm sure, is there. And her outcome, and she starts to talk by saying you should marry the 11th person you date. And everyone sits in the crowd going, because all the geeks are there going. But how did she get to the 11th person you date? And this is all about prediction intervals. Now, if we had random numbers between, well, you don't know what it's between. There's random numbers. Okay. 15 minutes. Or am I 15 minutes overdue or 15 minutes to go? All right. This is the last point, but this is a fun one to end on. So you have an unknown population of data. You know nothing about it, except that there are no duplicates. Since you know nothing about it, you've got to assume that there's no distribution at play. It's a uniform distribution, equal chance, 20-sided die, equal chance of 1 to 20. And that when you pick them out, they're picked out at random. It's just like dating. You meet someone in a bar and that's your first random sample. That doesn't go so well. And you get a bit of a feeling that there was something about them you didn't like, but you don't know what. So you date the second person. And they're a lot better. Just on this arbitrary scale of how good they are to marry or be with the rest of your life, they're much better. But remember, you don't know what the total goodness. You could just be about ready to meet Paris Hilton or someone awesome like that. But you don't know as a teenager. Remember, I'm talking teenagers here. Or Brad Pitt. I'm trying to think of the opposite end of the extreme here. So then you do another step and you go, oh crap, this is worse. Oh my God, why didn't I stay with number 2? So you're asking yourself in your head, the fourth sample, what is the chance that it's better than I've previously seen or worse than I've seen? Or if I restate it, what is the chance that number 4 falls within this boundary between 1 and 2? Does anyone know? Does anyone want to take a guess at the moment? So there's really only 4 possible chances for there to be it. It could either be above the second person you dated, between the second and third person. It can be in one of those 4 locations. And what are the chances of each of those occurring? Well, remember I said it's a uniform distribution and you know nothing about your data, so you have to assume 25% chance of each. So there's a 25% chance that the next person you date is better than anything you've seen previously. And there's a 25% chance that it's lower, which means there's a 50% chance that it lies within. Now all we're doing with prediction intervals, so by 3 samples, you're 50% certain your next sample is going to be within the boundaries you've seen. And if we extrapolate it out to the 11th sample, your 12th sample, you only have a 5% chance they're better and a 5% chance that they're lower. So you've found your 90th confidence interval, which is what we like in statistics to give a number to. So you should marry the 11th person you date. And, you know, I always say get interested at 7 and marry 11. So that's how I teach it, is that by 7 you've got an 85% chance that you got a known entity coming your way. And by your 11 sample, you're at 90% point. So now, that's knowing that it's a uniform distribution, we know nothing about the data. But what I said about cycle time and risk is we do know the shape of the data is a Weibull curve. So we can actually be very certain, if I just know the outliers, the minimum and the maximum, I can pretty much give you an exact curve that will pan out in reality for a large sum of money. So that's sort of what I'm trying to sort of innovate on and get people around, because in software we don't get many samples. We don't, and the samples we do get, we need to make most use of. So whereas normal statistics is about having thousands of samples, I think to do proper forecasting in software and risk, you have to work with very low numbers. And I mentioned reliability. Pratt & Whitney invented this field of how to work out when their engines would wear out based on this Weibull curve. And the US Air Force, there's a guy who, when he presented the Weibull curve, I think in 52, in 1952, he sort of said, I think this curve might be useful. And it's turned out to be the basis of almost every part of reliability analysis. The number of defects that you're going to have in your project. When you see that the project when you start finding less than you were previously and you're on that downward side of that curve, you can now predict what the number of defects are going to be in production at any moment in time. And this is actually done today in many companies. And what I'm trying to do is I'm trying to do the same thing for risk. That once we know that we're starting to get into the lower likelihoods of the risks, I can pretty much tell you how much work there is remaining to eliminate the remaining risks. Just like they can tell you that, there's a part. And it's just based on that common sense that there's n number of things that can go wrong, unlikely to be all of them, equally unlikely to be just a sum of them, just none of them, or just one or two. So you end up with filling in that permutations in the middle, and it turns out being this Weibull distribution. So with that, I have nothing more to say, really. Oh, how to sample at random. Split. I can't, no, I'm on camera. I'm not going to say that. So I was going to say split your sample population into two, male and female, and then date male and date female, but that doesn't work. But your point is whenever you can actually take a sample, take some samples and take another samples, work out what your distribution curve is, and if they match, then you're in good shape, that you actually picked these samples at random. If you always go to the same nightclub, you're probably going to get all the same style of people. It's not a random sample. So when you date wide. Thank you. Well,
Questions?
I know it was a bit rushed. I really apologize about the slides background not being transparent, but
Yeah, your Monte Carlo simulation slide, way back.
yeah.
Don't worry about it. Did you have to assume the risks were independent? Or
Are they correlated?
or are they not?
Well, I did to do the proof that risks will always turn out to be a Weibull distribution. In the real world, if some risks come true, there's you now affect that there's a chance that these other risks are going to come true. If you're having performance problems, chances are you're going to have memory problems as well. If you're having staffing problems with testers, you're probably going to have staffing problems with your release staff as well. So you do have to model those. So normally what that models is that when I bump one up, I know which the other ones are linked to, so they become more likely as well. I bored a couple of people. Anyway, thank you for coming. I simplify modeling here, but that's my day job.
Thank you.
Go ahead.
I have a sort of general question about integrated risk and Agile. It seems like we've been talking about risk management for software as if it were an engine, as if it were a self-enclosed piece of work. And I think in the past few years, the ecosystem in which software and systems exist has changed and has become riskier in the sense that our software is connected to the outside world, and we're dealing every day with cyber attacks and other kinds of malware.
Yeah.
So the impact on risk management for software development, in the Agile world. I'm curious to know whether, in your experience, all development is becoming more agile because there are these outside factors that come in and you have to have shorter release cycles to deal with them, or within the Agile world, how they're dealing with
these things. Yeah, that's a great question. I'll just paraphrase it if I may. It's back in '85 when I started. You wrote a desktop app and you shipped it. There was no network connection to the rest of the world. There was no other attacks. Nowadays, that's insane. Every time you deliver a bit of software, it is going to be attacked. If it's an online bit of software, if it's installed in a on someone's machine, it's probably going to open up an exploit that someone's going to leverage one day. It's actually, is it getting harder to write software? Are there more risks? Are there more things for us to worry about? And whenever I think it's just like my parents who sort of said, back in our day it was like X. I think in 10 years' time when people look back about what we're dealing with now, they're going to say the same thing, that, gee, you had it easy back in 2013. You didn't have to worry about fiber optic droids coming in and something like that. I don't know what they're going to be, but there are always new risks coming along, which is why it's such an exciting field to be in, because it's never going to stop. It's always going to get riskier. Now, Agile and the lean startup sort of style of methodology for entrepreneurship is trying to get you to break that down and run an experiment and deliver in smaller increments, both to cover your business risk and now Agile to cover your technical risk, that you're delivering incrementally so that you can sort of test in isolation. But on big projects, it doesn't work, because when you release even a small bit of code into an existing website, I was sort of VP of Travelocity.com and lastminute.com, everything had to be regression tested because we couldn't take a chance that we broke checkout through some inadvertent way of doing of some small feature somewhere. So yeah, I think unless it's a small isolated little startup, that's first couple of slides where we sort of said Agile. God, I don't think I can get back there. If I keep hitting this while I'm standing here, we'll go right away back to the beginning. But I think that top right-hand corner where I said we're in the ambiguity, where there's a lot of uncertainty and there's a lot of risk, that's where we are nowadays. And I think in 10 years' time we'll even be further up on that scale. It's tough. So your Agile practices are trying to cope with the technical risks, and your lean startup methodology is trying to cope with your business risk. Are they stable? Are there always new risks? Yes, there are. You got to adapt and find ways of dealing with them. I don't know what to say. You wanted a good answer there, instead of saying, no, it's getting easier. It's not getting easier. It's never going to get easier.
Yeah. Actually, I
Suggestions?
Just wanted to add to that. Where I am, we actually developed this web application. It almost doesn't matter what method we use. But then afterwards, we actually needed to do a security audit where they take the code and they go through, I don't know, some type of, I don't actually know what the security risks are, but they built it into these scans. Then you go through that, you remediate what you can, then you have it rescanned. So I would imagine if you start small, that first scan is less of a process. And then you can kind of remediate quicker and move forward that way.
I mean, you're right. So this is that bottom scale of the number of entities at play, where what Agile works good is when you've got one or two things you have to be worried about. I worry about security, and I worry about losing money through fraud. But as the bigger projects get, this bottom line here is like more of a larger website where you've got many more entities at play. And then when you get to a large corporate website, Amazon, Walmart, Travelocity, you're up in that top right-hand corner where you're being slightly reactive because you're in the middle of a recession, so you've got a huge amount of business risk. And the number of people you have to deal with and get to walk in the same dance card is just huge. And it's hard to do. It's tough. But who has a risk department in their company at the moment? Who has a risk program where people actually focus on risk? So there's probably 3-4 hands in the room. How are those companies getting by, not getting bitten by ridden by risks there that were inadvertent or unheard of 5 years ago. Probably all of them. Anyway, great question. Anything else?
Could you speak a little bit about learning curves as they affect someone's ability to estimate risk or deal with risk? And also, a question about the dating paradigm.
Sorry.
It's interesting because if you date someone, you date like a lot of people, they might talk to each other, especially with social networking. So what happens to
how does it affect your model?
Actually affects
That's great.
feedback, right? It's a feedback.
RateYourDate.com. Does that exist?
Wow.
RateYourDate.com. You heard it here first, folks. Worth the price of admission. Yes, modeling, I simplified it here to sort of say you model risks and they're all independent. When you bring new staff on, if you try and account for that staff risk, there's a learning curve. You have a J curve where the new staff coming on pulls down your other team members. I had that book, Forecasting and Managing Software, and it's 300 pages, and I scratched the surface of how you would model software projects. I started out doing this stuff just all in Excel and the off-the-shelf products, but it's now a custom language that I find I have to break down projects into 5 to 10 different phases, and each of those phases, I know that the staff hiring pattern is going to cause a longer, more uncertainty in the work that's going to be done, and that flows on and flows on. So I tend to model down to that level. But then I also model at the other end of the extreme. When you do weather modeling, you do multiple models and then you compare the results. You never model just one thing and expect it to be accurate. You always have a double check, some course vector that's if they don't agree. So for a company here in Philadelphia, I modeled their story points and risk ranges, and then I also modeled cycle time projections. And over a 12-month project, if they had to be within 5% or 10 days before I would actually go on the record with a forecast for that team and the project. So I never modeled just one direction. And they both have their positives and negatives. One handles staff competency better than one handles backlog uncertainty better. So if I can get them to agree, I'm pretty certain I've got a good model. But no, modeling is hard. It takes time to learn. You try and always have multiple models converge before you go on the record. Is the answer. But it's a big field, and at the moment it's a bit underserved. All right.
Okay, anybody else want to be in the raffle?
Thank you. Great questions.
And another round of applause for flying out just for this.